Hey, my name is Stan and I'm part of the Outflank team. We are a unit within Fortra that creates an offensive toolkit for red teaming and attack simulation. It's called Outflank Security Tooling, or OST for short, and it's a cloud-delivered toolkit which provides you with tools around initial access, lateral movement, privilege escalation, credential dumping, and all of the other stuff that you need for your red teaming operations. In today's video, I'm going to demonstrate a capability which we call Payload Generator. Payload Generator will help your red team create malware artifacts for initial access, persistence, privilege escalation, or lateral movement. So let me take you to the portal, and we can access Payload Generator in the interface menu, and there we have it. With Payload Generator, we need to go over configuration options to configure exactly what kind of malware artifact I want to create. And in the end, I'm going to click Build, where our backend will then assemble all of the relevant source code and create a freshly compiled malware artifact for you. So let's go. We first need to select the project which we are currently working on. And then I can select the kind of malware artifact which I want to create. For example, for initial access, it would make sense to create a rogue control panel applet. Throughout my configuration, if I'm ever in doubt what a certain option is, I can always hover over the question mark icon and there's the explanation. Also, under documentation, which is available here, all of the features are extensively documented. So we are going to create a rogue control panel applet. And for this rogue control panel applet, I want to execute a Cobalt Strike shellcode. We can generate it in Cobalt Strike if we go to Payloads and then to Stageless, Generate All Payloads, and click Generate. If you're using your own shellcode or if you're using another C2 framework, as long as you can generate position-independent shellcode, you're good to go with OST's Payload Generator. Also, we support .NET assemblies, which we can convert into position-independent code. So I've previously uploaded my Cobalt Strike shellcodes, and let me select a 64-bit option. There it is. Of course, embedding a Cobalt Strike payload as is in a malware artifact, it's a very bad idea from a static analysis perspective. So instead of embedding it, I could also fetch my shellcode remotely. We support things like domain fronting, etc. for this option. I could have the file available locally, but that doesn't really make sense in an initial access use case. This is more for persistence or priv-esc. Or I can use a OST predefined payload, for example, for creation of an admin user. But again, this is mostly priv-esc. Even if I go with an embedded payload, I do have options to hide my shellcode from prying eyes of static analysis. For example, I can encode my payload. I can encrypt it. I can add compression on top of it. All of these combinations are possible to make sure that we are going to bypass any static analysis by an antivirus product. So any detections on disk, because we inserted a Cobalt Strike shellcode, we will now find our way around it. But of course, evading static analysis is only the beginning, because the real challenge starts at evading dynamic analysis of some of the top-notch EDR products, which are out there. So for that, we support multiple injection techniques, and we keep on adding these on a very regular basis. So for example, we have the classic early bird injection, which is userland APC queuing. And you might think, well, this is not really that effective anymore against a specific EDR, but we have options to revamp it again. So for example, we have implemented a custom implementation of drip allocations and drip sections, which we can use to, in a very nifty way, allocate memory in a remote process, which evades many EDR products. Also, kicking off our shellcode directly with a start address of a thread, which is not backed by any side module on disk. It doesn't really make sense. So in this case, we can enable ROP gadgets, where we are going to use a trampoline in a Microsoft signed DLL to make sure that the injected thread will have a starting address which is backed by something on disk which is signed by Microsoft. Awesome stuff. We could even take it a step further, because if we do not want to inject in a remote process, we can stay within the current process. And of course, we provide functionality such as thread stack spoofing, including sleep masking. We have created a thread manager for Cobalt Strike Beacon explicitly, so that we can do some top-notch sleep masking for Cobalt Strike's Beacon. And all of this will help you to stay under the radar of any memory scanners of an EDR product. For sure, as a red teamer, you also want to set some guardrails. So you can do some pattern matching on which host name your malware will run on, or domain pinning, which is the Azure AD or AD name of the target which you are going to be targeting, all to make sure that your malware artifact will not run on a sandbox, or even worse, if it gets forwarded in a phishing mail or so to another company. You do not want that. So we support all kinds of guardrails. Social engineering to fit with your phishing pretext, we can support it as well. You can pop up a message box, hide the window of the application host. In a CPL, it doesn't really make sense, but for example, if it's an Excel add-in, we can hide Excel so that if the user closes, the user cannot close Excel, so that our malware will keep running in the background. All of these features we have available. We can impersonate a existing portable executable file by either uploading one, selecting one of the pre-configured ones, or in this case we're going to be using a random one. I'm going to click build, and right now our backend will assemble the relevant parts of source code. It will compile it, and there we have it, a fresh rogue control panel applet with a Cobalt Strike Beacon in there, which has features enabled to evade both static analysis as well as dynamic analysis. We have some of the latest R&D in here, whether it's using ROP gadgets, drip allocations, very nifty injection techniques, sleep masking, thread set spoofing, it's all in there. And you don't have to write any code yourself. The only thing that you need to do is understand what kind of techniques you are combining to make sure that these techniques fit the target EDR which you're up against. And of course, we have the documentation as well as our Slack community to help you with that if you are up against a specific EDR which you haven't ever encountered. So in this case, I can download my zip file. Let's unpack it. And there we have it. We have a README file, a build file with all of the settings which I selected, an IOC file for your archiving, which contains the hash of the malware which we just generated, and a specific CPL that we can now deliver, for example, via WebDAV or in a password encrypted zip file, or whatever your approach is for initial access to your target. In this case, let me just copy and paste it to my target system, which is right here. It's my lab system. I'm going to double click it in this case. And as we can see, we have a new beacon coming in right here. All right, so this was Payload Generator at a very high pace overview, just for initial access use case only. In another video, we will, for example, demonstrate how this tool can be used for privilege escalation or creating persistence binaries. Thanks for watching, and if you want a demo, do not forget to go to outflank.nl/OST and request your demo anytime soon. Thanks.